prove that triangles are similar, there's a few ways you can do it. If you can show that there's a sort of a constant scale factor that's been multiplied through, then that's one way of doing it. So for example, if I say these are both squares, 2, 2, 4, 4, then you can see that you have to multiply by 2 both times, so it must be that they're similar. Another way of doing it is to say that the angles are the same, because that means that you've just sort of enlarged one of them to make the other one. So if we can show that, because actually the first method isn't going to work in this case because I've only got 3 lengths. So if I can show that the angles are sort of the same, so I'm looking at this triangle here and comparing it with the bigger triangle. So let's go ahead and do that. So how are we going to do it? So you might say that angle, actually there's a shorthand way of writing angles, so let's use that. Angle BAC in the large one is going to equal angle DAE. That's this angle here. In both cases I've just sort of used slightly different notation for it, but BAE is here, DAE is here, and it's because it's a shared angle. Right, that's that one sorted. What about these two? Well, these two are equal because we've got parallel lines. They are corresponding angles. You can sort of see an upside down F going on here. So you might say that angle DBC is equal to angle ADE. So this is the bottom one here, and this is this top red one. And I'm just going to give reasoning because it says prove. I don't know, it's just a good idea to give you reasoning throughout. Corresponding. Nearly there, we've just got to deal with these two and exactly the same thing. These are corresponding, so I can say that angle AED, that's this one here, is equal to angle BCE. That's this one on the bottom right. Again, corresponding. And because the angles are equal, that means it's similar. Therefore, they are similar. I don't think you need to write anything else. I think that's enough. Okay, calculate the length of AC. Well, for this purposes, it's probably best to draw the triangles separately. I think that's a good idea when you've got similar shapes but kind of inside one another. So let's do this. This is ADE, and we've got 4 along the bottom, and we've got this is 5.8, and I've got this larger one, A, B, C, and then this is equal to 12. I think it's a bit clearer now how to work this out because I need to think, what have I multiplied by? It's always multiplied to go from 4 to 12, and that's 3, and that's our scale factor throughout. So if I want AC, I then need to multiply 5.8 by 3. This is a non-calculator question, so we have to figure that one out. Well, I'd probably do this by doing 3 times 6, which is 18, and then minusing 3 lots of 0.2. So it's going to be 18 minus 0.6, which is going to be 17.4. You could do it. You could do 58 times 3 and then divide by 10, however you want to do it, really. Okay, finally, find the ratio of the area of quadrilateral DBCE, oh, I don't like this, to the area of the triangle ABC, so the large one. All right. Oh, okay, so let's say let's look at triangle AED, and let's say it has area of X, let's say. Right, then triangle ABC, what area will that have? Well, I know the lengths are multiplied by 3, and actually what happens is that because all the lengths are multiplied by 3, like the base is multiplied by 3 and the height is multiplied by 3, when you work out the area, you have to account for that twice. You have to times by 3, but then times by 3 again. So the area scale factor would be 3 squared, or 9, and then the area would be 9 lots of x. And that means we're nearly there because the area of DBCE, that's this bit here, that's going to be this 9x minus the x, it's going to be 8x. And that means we're pretty much there. So the area of ABC is this really large one, that's going to be 9. And then the area of the quadrilateral is going to be 8. Like that's the ratio. So 8x to 9x, which we can then simplify to 8 to 9. That's the trickiest question in this paper so far, I think, but hopefully that makes sense. We've done this similar triangles question.